Morning, sir,
Oh,
and all
okay.
uh, colleagues.
Participants. So around 25 participants are here.
Yeah, sure.
Good morning, sir.
Shall we wait for 2 more minutes?
Yeah. It's 9:29 now.
Yes, sir. A very good morning to everyone. I'm Chetna Pujari. I welcome you to the day 3 of 5-day faculty development program on cybersecurity. So, as you know, in today's session, we have two speakers. So, first session is titled Biometric Solution for Cybersecurity, which will be handled by Dr. Shrikant Prabhu, Associate Professor, Department of Computer Science, MIT. Welcome back for this FTP, sir.
Thank you.
And followed by that, Mr. Akshay MJ will take over the session. So now I request Dr. Prabhu to please take over the session. Thank you.
Yeah, I hope you're able to see it, right? Are you able
Yes,
to
sir.
see it? It's
Yes,
visible,
sir.
right?
It's
Slides. Okay.
visible.
Yes,
It's
sir.
visible.
Yes, sir. Visible.
Biometric solutions for, I made a mistake there, for cyber forensics. So this is my topic today, as I am the first speaker. Yesterday we had covered cyber forensics, cyber loss, and then forensic science and legal suits was the third talk. And we had a small hands-on session wherein we learnt about facial analysis, the basic things, morphology, anthropology, and all concepts linked with morphometry and anthropometry, right? And what we have seen from yesterday's talks, that computer forensics or cyber forensics have got a lot of link with just forensics. Only thing is, in computer forensics we bring in computer machines into picture, and computer forensics have got lot of link with cyber security, and also with cryptography, and also with artificial intelligence, machine learning, deep learning, neural networks, right? Tomorrow I will show a basic picture like how you can tackle these subjects in a logical sequence, right? Having said that, what do you mean by biometric solutions, right? Biometric, this word has got two parts, bio and metric. So bio is a biological property, metric is a measure. Biological properties can be fingerprint, it can be face, it can be a retina, it can be ECG, EEG. Remember, ECG and EEG, they are behavioral biometrics because they keep fluctuating for any person, right? DNA, even keystrokes, whatever we type on the keyboard, they have got certain gestures with the fingers, right? So keystrokes, and all others, basically whatever we see in a society in terms of biological property which are being measured. And what are the solutions? So when I say solutions, I need to know some methodologies, say in 1 hour, so that you get a clear cut picture Like what are we doing here and how do you find answers so that when you go back, then you can apply it in your problems basically, right? So today my contents will be biometrics. Then I'll be showing you retinal data, gastrointestinal data, stroke data. Now, why I am showing the healthcare data? Remember, yesterday I have told you if everything is normal, then forensic is just a case study to find the properties of those data. If all the data are normal, but if data are abnormal, say that there has been a situation where there has been a crime. So when data are abnormal, you will have certain abnormal features. So these abnormal features mainly will be healthcare features, right? If healthcare features of any person starts to degrade or starts to deteriorate, then you will have healthcare data coming into picture in forensic sciences and specifically broadly here computer forensics, basically, right? Now, just a small remembrance what we did yesterday in morphology. It is study of things through shapes. And I have shown you different pictures and you have given me all the correct answers. Many questions were asked, right? And we had a lengthy, very healthy discussion on that, on this particular topic. Now, three basic biometrics, what I'm going to show you first: fingerprints, which work on minutiae points; faces, which work on feature points; retina works on bifurcation points; and also optic disc and macula. Right. So these are all the different features for these biometrics. Remember, whenever you are working on biometrics, let us not now bring in the word cyber forensics. I'll bring it afterwards because I'm going to show you something about veterinary also, right? So whenever we talk about biometrics, the first main thing we have to do is feature extraction. And these are the three types of features what we have: minutiae points or feature points or bifurcation points, optic disc and macula, depending on what data we are using basically. All right. Now, what are the methods used in short? So let us just discuss about this and then I will show you how it works. So for fingerprints, like yesterday I have shown you certain digital fingerprints, you have to extract the bifurcation points, right? So these bifurcation points lie on bifurcations or they can lie on ridge lines basically. So you understand what I mean by bifurcations: one straight line breaking into two smaller parts. A straight line is a ridge line basically, and mark the endpoints of that. And then you match the distances among those points. So when you have a set of n points, n for nose, the number of distances among these points will be nc2, permutations and combinations basically, right? nc2 basically. So calculate all those distances and then we use a small neural network algorithm called as coherent network to do the matching part, right? Now for faces, you generate faces, extract the feature points and then match by principal component analysis and Bayesian classifier. It should be and or. So when I say principal component analysis, in short, the different steps are: extract the dominant features, what you require for the problem, only you take that basically, right? Then get the eigenvalues, eigenvectors, right? Basically, eigenvalues are markers for those dominant features, right? And then those dominant features will be pointing in certain direction. So those are called as eigenvectors. So extract those values, eigenvalues, eigenvectors, and then go for classification. Bayesian classifier basically works on the probability theory of Bayes' theorem, right? Conditional probability. So this is what the face recognition is all about. But today I'm going to show you one extension of it, which is called as face generation, for which the glimpse was given yesterday. I had shown you certain small snippets of parts of faces like forehead, face snap, and mustache. Basically, remember, now I bring in this word. I bring in this word called as cyber forensics. So remember, yesterday Dr. Shankar Baknawar told forensic does not have any meaning if crimes are not there inside. So it is correct. But that doesn't mean you will not take normal data. So first you have normal data and then you take abnormal data. Now, when you look at these forensic data,
सेशन चल रहा है.
yes, please. Yeah. When you look at these forensics in terms of computer science, basically, right?
मैंने कहीं ऑन तो नहीं रखा है ठीक है मैंने मुझे बदल दिया अब बोल रहे बहुत बिजी हो गया तो मैंने
Yes,
बोला
please, just, yeah. Thank you. Thank you. Right. Yeah. So When I am talking about this Bayesian classifier, wherein we use Bayes theorem, basically, and yesterday the glimpse what I showed you different parts of phases. Now I can bring in this word computer forensics because those parts of phases have to be captured by digital cameras or surveillance cameras. All right, it makes a lot of sense. And even Dr. Shankar Baknawar, in his last part of his talk, he showed certain examples of cyber forensics where different surveillance camera pictures were shot and then it was produced before the lawyers, that is a jury, and then the case was solved, right? And the last one, that is retina. I'm going to show you how do you superimpose retinal data and then what it means when we talk about ground truth. And these words ground truth I spoke yesterday also, right? Now this is very clear now. What do you mean by biometric? Bio plus metric, it is feature based or ratio based. Yesterday I had spoken about ratio. These days people are working on biometrics specifically in cyber security or in cyber forensics through ratios, right? Ratios means there should be two lengths, length 1, length 2. Then you divide L1 by L2 or L2 by L1 and you have to prove that they are unique basically, right? Like yesterday what I have shown you. Feature based is what I'm going to speak today more in detail. And human biometrics are these. I'm going to show you animal biometrics, faces and claws. Now, why do we require this? This is required where you have agricultural lands in a smart city. So many animals will roam about in agricultural lands. So we need to find out whether these animals are going to cause destruction to the crops or no destruction to the crops. So we capture their faces depending on what kind of animals they are, say cheetahs or leopards or lions, wild dogs, hyenas, Rottweilers, Saint Wheelers, Labradors, and you get a picture of their claws and try to recognize and match. This is a very hot topic these days in the developed countries. Lot of research is going on in the African countries by the American universities, specifically Stanford and Berkeley. So they are trying to find out different domains of animals, and they are trying to revive many of the animals which have become extinct, like the white tigers or even the white lions, and many of those canine animals, basically, because to maintain the ecosystem, right? And there are a lot of things linked with crime also because many of the animals are killed. So when dead bodies are found of animals, we need to find out whether they were killed or they died because of natural diseases, right? So it's very interesting topic to work on these. Now, this is a picture of a digital fingerprint recognition. So I have an input fingerprint. I have extracted all these minutiae points. You can see, right? So codes have been written to extract these points. So you can see here, there are say a set of say around 15 to 20 points. Some of the points are exactly where they should be. Some of them are not exactly where they should be. So these become false positive for bifurcation points. Anyways, nevertheless, if at all you have been asked to match it, so the basic algorithm what I apply is if I have been given a set of 15 or 20 points, the number of distances possible will be say 15C2 or 20C2. Extract all those distances and store them in a database, basically, right? And then we applied the backpropagation algorithm. In short, I will tell you what is backpropagation algorithm. There are two things in neural networks. One is called linearly separable problem. Another is called as not linearly separable problem. Linearly separable, not linearly separable. When do you say a problem is linearly separable? When you can segregate the outputs clearly on either side of the line. Suppose there is a line. If above the line you say all the outputs, the set of outputs are ones, and below the line you say all the outputs are zeros. So you can clearly segregate by using a line ones and zeros, either above or below or above. Then you say the problem is linearly separable. When the problem is linearly separable, you will have an input stream of data, and from the input stream of data, you will directly go to the output layer. You will not have any intermediary layers, which are called as hidden layers. When a problem is not linearly separable, then example for that, that means you cannot fit in a straight line to segregate the outputs as zeros or ones either above or below or below or above. The XOR problem. Imagine 0, 0, 0, 0, 1, 1, 1, 0, 1, 1, 1, 0. This is the XOR. Plot these coordinates on the XY plane 0, 0, 1, 0. So on the x-axis, 1, 1, it will be in the first quadrant, and then 0, 1, 0, 1 will be on the y-axis. Now, what is the output of 0, 1 and 1, 0? It is 1, 1. 0, 0 is 0, 1, 1 is 0. Now imagine, can you fit in a straight line so that you can segregate the output zeros or ones clearly on either side of the line? The answer is no. You cannot fit in a straight line. You need to find the equation of that plane which can segregate those outputs. So here you cannot have an input stream directly going to an output layer. You have to have a set of hidden layers, hidden layer 1, hidden layer 2, hidden layer 3, and in each layer basically you will have neurons, you will have activation states, activation functions like sigmoidal function, signum function, binary function, which are all non-linear functions basically. Now imagine you have a target output and an observed output. Observed output is what you get, target output is what is set basically. If they are not very close in one particular threshold, that means you will do a feed backward network. So feed forward, feed backward, and you will correct the weights. You cannot correct the inputs because inputs will remain same. So input into weight minus bias, basically summation of that. So I think most of you will be knowing it. How do we do it? So basically this is the basic crux of the back propagation algorithm. So basically in all the scientific experiments, the target output and the observed output will not come close in one particular threshold. How do we find these thresholdings? So there are two techniques. One is called the Kapoor's thresholding and there is called the fuzzy thresholding. A thresholding technique which depends on fuzzy sets is called as fuzzy thresholding. A thresholding technique which depends on crisp sets where you are sure the numbers are 100% something, either 1 or 2 or 3, whatever it is. So these are the ways of solving this problem, and we have a matched fingerprint here basically, right? I'll show you the running of this before I go forward, right? So you can see here, these are running. So these are all minute points, the feature points extracted, and this is the matching basically. So you can see how clear the fingerprints are. All the pre-processings have been done basically here, right? I can show you now what are the different types of fingerprint what you have basically, right? So this is called as a loop fingerprint, loops basically, right? These are all loopings basically, right? You can see this is called as an arc fingerprint. So there are different arcs here. Can you see here? These are arcs basically. These are partial fingerprint arc, and the full match we are getting here basically, right? And these are called as fingerprints, which are in the sea basically, right? So this is how it looks with all, and this is a matching part basically, right? I can show you one more here so that it becomes clear when I show you face generation, and then we'll see reuse how it is done basically. All right, okay. Just go here. You can see this is running basically. All right, I hope you are able to see it. So this is how it works basically. So these are all certain techniques for doing a fingerprint matching. Remember, fingerprint matching is totally different from palm matching, right? So palms will have other features that also can be used for computer forensics, because many a times when crimes take place, hands are used, right? So palm matching, right? Now let's go to the next one. Right. Now this is an interesting prodigy. This is what is called face generation, right? Now first what I will do is I will run this, then I'll talk more on this, right? This is this is one of the main data which is used for computer forensics, right? Let's see that. Yeah. So now I'm running one small code here, right? This is a template based method. First template, second template, and third template basically, right? And I'm stitching it. So person one's hair, person two's face snap, the eye part, and person three's mouth. So with respect to person one, it is 33% correct, 1 by 3. With respect to person one, I can permute the eyes. With respect to person one, I can permute the mouth. Now, yesterday I was talking to you about the victim and the witness, and there is a jury. So a lot of questions will be asked. Is this the person whom you have seen? Or is this the person whom you have seen? Or is this the person whom you have seen? Remember, the basic templates are person 1, person 2, person 3. And I'm permuting among them, basically. Okay. Now, somebody might say, the victim might say, no, the hair was looking somewhat different. This is correct what you have done, the face snap. Hair was looking somewhat different. So permutations once again. Is this the person what you have seen? Or is this the person what you have seen? Or is this the person what you have seen? So different types of permutations, different types of faces are being generated. These are all taken from surveillance cameras, basically, datas, right? And these have all been stitched, basically, right? Now, the idea behind, if we extend this, if we take another template, the whole template is changed. It is person 3, person 4, person 7. Person 3s, person 4s, person 7s. Now, once again, let's say mouth is not looking correct. So, is this a person what you have seen? Hair is not correct now. So, hair fixing can also be done. Is this the person? No. Is this the person? No. Is this the person? Yeah. Now, this hair, I remember, belonged to a cycle rickshaw puller in West Bengal. Right? You can make a judgment, and this is the idea of tomorrow's talk on graphology. How you can make judgment on different types of data, right? So if you look at this hair and if you look at this hair, right? Now this particular hair is of a person who is working in a mess, right? In a hostel cooking food. So there are certain judgments what you can make, right? Because this hair have got some curlings. Here it is normal, but here it is abnormal curlings. Can you see? So this happens when you're working in a kitchen because of the gas which is flowing in the kitchen room, right? So you can easily make out that this face belongs to a person who was working in a kitchen or who is working in a kitchen, right? Another one I can show you. This is once again, this already has shown you. Yeah, if you look at this is almost uniformly spread, right? But little bit bulge is there, right? So you can make out that this also belongs to a person who is working on the work site, and this belongs to a person who was working in a cycle shed, right? In one of the engineering colleges. So there are a lot of judgments what you can make from face generation, basically, right? If you change the hair now, once again, this is changed. Now with respect to person 3, remember template is same. This is not changing. I'm making changes here. Person 3. Now, yeah, this is person 3. So once again, this also belongs to a person who is working in a mess. He is no more now, right? He was very close to me, Adi Narayan. He's no more. So this is 100% correct. Why do you say 100% correct? You can see the breadth. Breadth is equalized. Even the skin color is equalized, basically. All the skin colors, right? So it is a classic software and a classic program written to show you how we can generate faces, right? And remember, all these data these days we capture from surveillance cameras, not from digital cameras. But you can have both the jurisdictions. You can keep a digital camera, you can take a surveillance camera, so that when the case is presented in the court, it is very clear how the data are basically. And even the jury can give a better judgment in terms of either a crime is committed or a crime is not committed. What it can be anything. It can be a theft, it can be a murder, it can be abuse, or it can be anything else basically, or it can be in any type of gender also, because many a times genders are involved when crimes happen. So anyway, I'm not going to talk more about that. It should be very clear now what can happen in a surveillance camera and how we can generate data basically. Now the question is, can we generate data on digital fingerprints? Can we generate data on retinal data? The answer is no. You cannot generate, you cannot stitch fingerprints of different people. It makes no sense. Neither you can stitch in retinal data. And it makes no sense to even reuse data from here there. Neither you can take any data from here in ECG, EEG, right? ECG means which is linked with the heart, right? Many a times when criminals are caught, so they are taken to hospitals with the tight security, their heart rate is checked, their BP is checked, and then findings are done whether they have myocardial infarction, ischemia, any kind of diseases, missing heartbeat, or anything else basically, right? So that when the jury gives a jurisdiction, say the criminal should be imprisoned or should be hanged till death, so his health condition has to be known very, very clearly. So there are a lot of sometimes I should say prejudices when we work on computer forensics. And the word is very clear, it's always linked with crime, but when you take crime data, you have to have normal data also basically. All right. Okay. Right. So this is all about. So here basically facial stitching is done, supervised machine learning. I'll come to it basically, the basic picture of it. And here you can get physical data of a person more than once, right? The meaning of more than once is different variations you can get of the same person here, right? Okay. Now this is one small program wherein I'm inducing certain noise in the input. And this is the talk next by Akshay Javital. He'll be talking about information abuse. How we can insert certain extra information which are called as noise. Right. Yesterday I was telling you about steganography, but I did not talk more about it because that was not the idea of the talks what we are giving in this workshop. Perhaps if a workshop is kept on steganography, I can talk more about that. But the idea is very clear. If at all any noise is induced inside an image, at the destination, can we get the original data and we remove that particular noise? And what these noises can be? Can there be passwords put inside? Or can there be any other secret information, the information of somebody else's family, some spousal data, children data, right? You are sending through one image which is not yours to somebody else, so that that particular person who is somebody else can get some private information of some person basically, right? Which is not a good idea. So that is a basic thing what people do, criminals do. So when somebody wants certain private information of some family, they ask their friends who are in close contact with that particular family. And if they are very tech savvy or they know certain softwares how to send hidden data in an image, they will do it basically. So remember, there should be a third person involved. There is a criminal, there is a third person involved, and there is a victim. Basically, victim's data is taken by third person and it is embedded inside an image and sent to the criminal. Then the criminal will start attacking the victim. So what usually happens in the court is the criminal, the person who supplied the data will be caught. Many times it happens in India. The person who supplies the data of the victim. So this is what the story was around 10 years back, the triangular story of crimes, right? How a third person comes into picture. There are many examples for this, like the Jasika Lal murder case where Manu Sharma was involved, right? Or even the Dhananjay Chatterjee Hetal Parekh murder case, right? I'm not going to talk more about the jurisdictions here, how these cases were solved. But in short, I can tell you about Dhananjay Chatterjee Hetal Parekh murder case, basically. In 1990, this girl, Hetal Parekh, she wrote her 10th class board exam and she comes back to her flat. right? She's from Calcutta, but her family is no more there now in Calcutta. They are Gujarati family basically. They have gone back to Gujarat. And this girl comes back. It was in the month of March, and she was murdered at around 1:45 in the afternoon after the board exam gets over, CBSE, right? And what happens is one eyewitness, one of her friends told, at that time there were no surveillance cameras. So one of her friends told that I have seen this girl going to her tuition teacher's house, another flat. So, and that girl went and came out. So he was a maths teacher, and this friend of hers asked Hetal Parekh what happened. So she explained everything to her maths teacher that the question paper went like this. He also told all the best wishes, and she comes out and she goes back to her flat. Around 2:15 p.m. in the afternoon, Hetal Parikh's mother goes to a shop, basically, goes to a temple, basically, right, in Calcutta. And yeah, not 2:15, around 1:30, I think, 1:30 in the afternoon, because 1:45, the time was given when she was murdered. So what happens is there was a watchman who's for that building. His name is Dhananjay Chatterjee. He's hanged. He's no more in the year 2004. So beside dead body of Hetal Parekh, they found one necklace and they found one watch. And that necklace and the watch, it belonged to Dhananjay Chatterjee, right? They had the proof of it because Dhananjay Chatterjee was wearing that necklace before and the watch, so they knew these types of objects were belonging to him. But this fellow ran off. He went to a place called as Bankura in West Bengal, to his house, and he was hiding there. Somehow they catch him, and they proved that the necklace was his because he was a poor guy, you know. So he confessed that this necklace is mine, this watch is also mine, but actually the watch was not his, because the number what was there, the secret number which was there, the barcode which was there in the watch was not matching with the watch which was found, which was actually belonging to the Hetal Parekh's family. They said that he has stolen this watch from Hetal Parekh's house. All right. So Dhananjay Chatterjee, when it was asked, he said, yes, this watch was there in the house. All right. But he said, I have not stolen it. So they proved it. The numbers were totally different. The actual number and this number, right? And this watch was found near a dead body. So afterwards, lot of investigations were done, and because certain objects were found which belonged to Dhananjay Chatterjee, one torn shirt was found of Dhananjay Chatterjee in his house, and it was proved that he did the crime. He was given life imprisonment. So certain sets of computer datas or datas which are taken from the machines were barcodes. One barcode which was found in the watch. But in those days, computers were not there. So they were machine datas in those days, basically. Right. So why I'm saying this is computer forensic will come into picture. Now the case continues. He got life imprisonment. So in 2004, he was going to come out after life imprisonment. He was 42 then, right? He was 28 when he was imprisoned. He was 42. Immediately, this girl's dad put a case in the Supreme Court because he got scared. If he comes out, then he will kill me. So basically, he put a case in the Supreme Court. And when the case was put in the Supreme Court, the then President Abdul Kalam, he said, no, this guy cannot be pardoned. Not because he said that, because the jury said that. So he cannot be pardoned, he should be hanged. Right? So hanging case was given, but it was delayed. It should have been done in the month of June 2004, but it was done on August 14, 2004. I remember early morning 4:30. All right. Now, in the year 2016, that is after 12 years of his hanging, Indian Statistical Institute brought in a forensic report, and they mentioned very clearly that this guy was not involved, right? All the logical clues showed that. Now, clue number one, what they said was, the watchmen who were there below, they were saying, it seems we have seen Dhananjay Chatterjee going to this flat around 1:30. We have seen through the balcony. But the forensic science department in the Indian Statistical Institute clearly says that we cannot see the balcony from the gate. So it is ruled out. Point number two, the watch also, which was supposed to be stolen by Dhananjay Chatterjee, the barcode was not matching with the actual barcode in the watch from where it was bought by Hetal Parekh's family. Right. And the third point, what they said was, it is very academic in nature. I'm quoting it here. It was a case of an abuse on a girl. So they said that there were no marks found on the upper part of her body and her head was crushed. So what they say is, this girl, when she came out of the examination hall, when she came back to her house after meeting a tuition teacher, she might have had a relationship with somebody and she was murdered by somebody else. And the most logical clue what they gave was the murder happened might be after 15 minutes she had a relationship with somebody and the murder was committed by the mother. And the case was solved by taking all computer data in 2016, because in 2016 computers were available and are available, and it was around 26 years after murder. So they took all the cyber data, like including all the marks on her body and all the injury marks, and they came to a logical conclusion that there were two people involved, one who was a friend of hers and one who murdered her. And they said the whole this one suspicion went on one of the family members. All right, it is something like the Arushi Talwar murder case which happened in Delhi. But I'm not going to talk more about that because that is not the idea today. But yesterday Shankar Baknawar has given a lot of examples. So this is how a case is solved. But in India it takes around 26 to 30 years, and it takes even in other countries also if the cases are complicated, because to get evidences and to get clues, specifically cyber clues, computer clues, something like barcodes or even fingerprint marks on the body. So they were very logically seen on her head, fingerprint marks, and they were not matching with Dhananjay Chatterjee. So this is how it is solved. So take this example here. Now these kind of softwares can be used to solve these kind of complicated cases. Why do I say that? Because in a complicated case, you have got different types of biometrics which are embedded on a body which has either been injured by a theft or injured by a murder or injured by any kind of abuse, basically. All right. So this is what. So I'm not going to show you any kind of abusive data. So I'm just going to show you a prototype of how you can introduce this noise and try to remove it. Basically, I'll just run this basically there. Okay. All right. Right. Please watch carefully. This is the input data. Database is running here. That is what it is. So basically what we have done here is we found all the principal components. What is required, like eye sockets, eyebrows, nostrils, mustache, and the noise parameter, right? Then we took image plus noise minus noise, image subtraction. This is how it is. So this is a very small example, basically. So it is not that the facial biometric cannot give correct outputs. It depends on situations. Where are you going to use the facial biometrics, basically? All right. Okay. So complete this part. Now, this is a biometric which is used on pets, right? Suppose any pet from a house is lost, or any pet has entered an agricultural farm and left. Now you need to find out which pet it is. A Labrador, a Rottweiler, a Saint Wheeler, a Saint Bernard, or various kinds of breeds. I am very much interested in this topic because I myself have pets, a Labrador and a Saint Wheeler. Right, and these are the areas where people can work on today in India because lot of scope is there. So here if you see the shape features of the eyes and the bone characteristics. So if you see the bone characteristic of a pet, it has got a aeronautical look. This is like a nose of an aeroplane. God has given pets or dogs a good aeronautical look so that they can run fast. Even if you see these days the railway engines in the country, they have got aeronautical look. basically. They have got a sharp nose. So whenever a sharp nose is there, those objects can go very fast. And anyway, this is having life, basically. Now we extract all these features, basically. Eye part, nose part, and this is called as Delaunay triangulation. You put triangles, basically, right? To extract, because otherwise this cannot come in a circle or a ellipse, because there are dark parts here. So you have to extract the whole thing. These are the ear parts, another triangle, right? So, and then we do a matching, basically. These are all the canine tooth, basically, right? So there is an example here which I can quote. This murder case happened in Hassan, basically, right? In a family where a husband murders a wife and puts a case in the hospital saying that the wife has been bitten by a cobra, right? When a cobra bite is there, basically you can see they also have the same kind of tooth, these canine tooths. The distance of these canine tooths for a cobra cannot go above 1.2 I think inches, basically. So when they did a forensic analysis on the wife's dead body, unfortunately that day in the hospital, that doctor's friend was not there, who was supposed to carry out the autopsy report on the dead body, right? He was missing. So that case was sent to Kasturba Medical College, Manipal, in the forensic medicine department here, where I took this subject called as cyber forensics. Dr. Shankar Baknawar is from there only. So they did a forensic analysis of this. So they clearly found that it is not a cobra bite, and there were a lot of palpations in the hand. The hands were bloated. So what they found was there were injections given to this lady. That husband of hers did not know exactly at what point the injections have to be given, so that the distance can be exactly tooth far away, which is there in a cobra. So that is where he lost. So he gave poison to this particular lady, and those two poison bottles were found on the Agumbe Ghat. So the forensic team went there and they could find the poison bottles and the injections after doing an investigation on this man, because they found a clue that it cannot be a cobra bite, right? And this is how the suspect was caught. So classical example. So I have little bit deviated. I spoke about cobra because I was talking about the canine tooth. The canine tooth will look same for all these. I'm not talking of buffaloes or zebras or wildebeest, basically, right? So like this, we do an analysis, and when we do when we continued for the analysis, we could find different type of uh, this one claws, basically, of animals, basically golden eagle claws, bald eagle claws, great horn. So we did a basic classification of the different claws of different animals, basically. So one was classical matching on pets, another was claw recognition, right? So there are different types of claws, what you can see, which is uniform in shape, this is non-uniform in shape, this is bigger uniform in shape when compared to this, and all this, basically. Now this is required in computer forensics because these pictures can be captured by surveillance cameras. If an animal is dead or if an animal has been killed, only the claws are found, basically. So you take all the pictures through a surveillance camera, because surveillance camera will capture for all the days, right? And you can easily find out who was there also, and then we can do a matching on these claws, basically, right? Now why do we need it? Point number one, we require it because animals contribute towards tourism. Point number two, if animals have bitten anybody, right? So we need to find out which is that, because the animal will run away. So which is the animal which has bitten? So you can do a recognition like this or like this. Like this to find out the animal face, and then like this to find out the claws. Because if you know which claws has hit a particular human being, then that particular type of treatment can be given to that particular human being, because you know which claws has created bites, basically, right? So we can, because there will be a lot of abscess formed or pus formed. So to give an antibiotic treatment, we need to know which clause it is which did the harm on the human being. So computer forensics works in two ways, either in terms of crimes, which are organized crimes, or crimes which are non unorganized, like animals attacking human beings. They do it unknowingly, basically, right? So there are a lot of applications here, right? Now this is what is retinal superimposition. I've got two retinal datas. This is of the left eye, left eye. When I superimpose, you can see this optic disc, optic disc. So I gave an opacity. I gave an opacity where this should be seen more. These are called as macular datas, by which we are able to see. So these have been superimposed. So a lot of work is going on in this particular field also. I'll just show you the running and then I'll go ahead basically. All right. Okay. Right. Please see here now. Superimposed. Now, why do we require this? For authenticity? Because this is a biometric which cannot change in airports, right? So you want to store all the data in log files so that entry point is very clear, exit point is very clear. So while entry you take, while exit you take. Superimpose, right? You can see. Then the other areas where we can work on, if this is captured through a retinal gun, is on disease recognition. So I'll just talk in short what it means and I'll end with my talk there. Okay, right. So this is what I showed yesterday, and now I'm coming to facial analysis. This already I've spoken. So this is another area where computer forensics will come into picture, medical data. So you can talk about disease recognition. This is retina of a person which is deceased. That is diabetic retinopathy here. Disease of retina due to diabetes. You can see the certain features here, exudates. This comes because of diabetes. If you look, it comes in four quadrants. If you divide this in four quadrants, the exudates are seen in four quadrants. So this is called as severe non-proliferative. Non-proliferative means it's correctable, but it is severe. Mild non-proliferative, moderate non-proliferative, severe non-proliferative. Then there is one more, severe proliferative, which is not correctable. So, if at all, now in computer forensics, if a criminal is caught, you can do certain medical investigation, whether this criminal is having any kind of pathological disease. Specifically, if there is a thyroid problem, so he will be very anxious, he will get a lot of negative thoughts, he will get a lot of sensual thoughts. So, you can make certain conclusions why this person committed a crime. Many a times, people who commit a crime will have certain pathological problems, or they can have psychological problems like schizophrenia, depression, mania, panic. They can have suicidal thoughts, or they can have even obsessive compulsion disorder, OCD basically, right? So a lot of things which we can do. It is not only psychological patients, but sometimes psychological patients can create problems in the society. So can we forecast that? It becomes very interesting, right? This is a gastrointestinal data. You can see here, this is the entry point from this endoscopy data basically. And you can see the vasculatures here. These are all non-uniform basically, right? So this is cancerous. So there is a cancer here basically in the stomach. So you can see whether there is a cancer in the esophagus or the stomach or the rectum in the anus part basically, right? They are called as polyps. So here also, if there is crime data of any person, many a times these days, endoscopy is done on the criminals, right? To find out what are the conditions internally inside the body, right? Because many a times criminals can do, I said yesterday, human bombing and suicide bombing. So if a bombing has happened, you cannot get the body, it will be dead basically. But you can predict if the person is alive, whether this person can commit a bombing, something like a human bombing, implanting the bomb inside. Or sometimes nowadays even copper implants also are being done. So all these things can be found out using medical information of any person. Once again, there is no gender bias here. It can be a male or it can be a female in either of the case basically. All right. Okay. Now this is the brain stroke data basically. Now this particular person was basically once again he was caught. He was in the army, and in the army they found that he is having paralysis and he cannot be continued in the army. So this is severely affected. This is a left side of the brain, you can see here. So there was an investigation done, and this person came to New Delhi, and he said in AIMS that I don't have high blood pressure, I don't have stroke. Lawyers advised him, but when he came to AIMS, he was put in the ward. In the ward, they found that he doesn't have high blood pressure. So how can he get a stroke? But when he was put in ICU, his blood pressure rose. Now, what is the reason for that? In the wards, take the self. So his lawyers advised him, you take the medicine yourself and you show that you don't have blood pressure. But this poor fellow did not know that he will be sent to ICU also, because in the ICU only the nurse can give you the medicine. So like this, he lost the case in the army, and further promotions were not given to him because he told a lie when he was caught with high blood pressure and certain types of stroke there. I will show you certain stroke data also, how it degrades basically. So these are all some data. These are all gastrointestinal data. These are all stroke data arranged. I will show you now how it looks at the end. So these are all the study of retinal data, normal once again. So we can see here three retinas, how their features are extracted, microaneurysms, hemorrhages, exudates. So if anybody is interested to work on this, on computer forensics in terms of disease recognition, so you can take one data and work on it, because you cannot work on all, so one you can work. So this is how the vessel extraction is done, segmentation basically. This is one model here which I have defined. If it is abnormal, what do we do here? Abnormal does not mean crime data, basically deceased features are there, that's all. Normal, what do we do? Authentication of the retina, basically like a biometric. So abnormal can be only deceased, or it can be deceased and crime, or it can be only criminal data. It depends on human psychology. Perhaps today the third talk is by a psychiatrist, right? By Dr. You can ask him something like that. So this is how the points are extracted. You can see these points have been extracted here, right? So these points are basically marked on the ground truth, basically. So this is how we do retinal recognition, basically. So different types of bifurcations I told you yesterday: capital Y, capital T, right half T, left half T, basically, right? So these are all feature extraction. These were the matching values what we got. And the last one, so artificial intelligence depends on machine learning. Machine learning depends on neural networks. Neural networks depends on deep learning. So finally, my team's talk, last talk tomorrow will be on AI by Dr. Ashwini from Forensic Medicine and Toxicology, right? He's also one of my collaborators. So this is how a deep learning network looks like. And in this deep learning network, basically we are classifying all the data, retinal, gastro, and stroke. We have all the convolutional networks here, different poolings, and the ReLU function, which comes from Sigmoidal, basically, all right? So this I will show you tomorrow, how you can do a retinal analysis and how you can say whether diabetes is improving or becoming bad, basically. So is that diabetes getting controlled by looking at retinal data? But remember, every diabetic will not have retinal data affected. But if the retina is affected due to diabetes, so many a times those patients also will have diabetic neuropathy. Their foot will be affected. So they will have numbness, pin and needle sensation, deep vein thrombosis, etc., etc. Right? So this is how it looks like even for a gastro data. So gastro, it looks like this basically outside. This is inside basically. This is cancerous. This is severe cancer. The brain data, and this is how tomorrow I will show you the analysis on this also. And that's it. So basically the accuracy is what we got. Now last one, I will just show you all the data what we have here. It becomes very clear, right? Right. You can see here now how the stroke is changing. So I have forensic data here. Can you see this? The stroke is increasing. See this? See this? See this? Is increasing, the
Yes, sir.
white part. Right. See this? See this? So this was a forensic analysis which was done on that particular doctor who came and said, I don't have a stroke and blood pressure. Here he was all right. He was a fool who said that in the Nepal hospital. So he was referred to all India Institute of Medical Sciences. Then his condition became bad. They did an narco analysis. All sorry. Right. So some other data, what I can show you. We are planning to work for a PhD on this, but I cannot share these data because these are all data taken from a hospital for which we have a ethical clearance. So you can see these gastro data. This is not, this is mild cancer. This is severe. The patterns have changed. Here it is not relating to crime, but it is about abnormal data. So be very clear about it. Severe cancers, basically, right? Cancerous data, only one particular part is affected here. The vasculatures are changed here, right? And it is spreading here also. This is normal. You can see all the features here, right? This is normal, basically. This is once again cancerous, right? So if at all I have to summarize, right, my yesterday's talk and today's talk and the hands-on, because tomorrow I'm going to talk about anthropology and morphology, right? So people who are interested to do their research, write research papers as PhD, or would like to have a startup, right? Some people will be interested to have a startup basically through a copyright or a patent, or want to write a master's thesis. This is a very good area to work on, cyber forensics or computer forensics. Right? Either you can work on only normal data for authentication like fingerprint, face recognition, retinal recognition, or you can work on abnormal characteristics which are deceased characteristics, only deceased. Very interesting, because what do you mean by deceased characteristics? They are against normal characteristics, so it is called as bad health basically. So you can put it intermediary, crime data, good data. In between good data and crime data you can put the deceased characteristics. Then you can add basically the computer part of it, because you can clearly say that you're capturing all the data through a machine basically, right? And the different biometric solutions basically. Now remember, each data you can take it to be biometric because they're all biological, even gastro data, right? We are working on arthritis. I'm co-guiding one student in KMC Mangalore on arthritis, right, with Dr. Yogesh Kamath. So we are looking through graphs, like the sway movements, right? What is the threshold by which you can say that this person is going to fall and is having mild arthritis or moderate arthritis or severe arthritis? Once again, it can be either deceased, or it can be even a criminal who is suffering from arthritis. A criminal can have diabetic retinopathy, diabetic neuropathy. So if there is a disease there, and if he or she is a suspect, like what yesterday Dr. Shankar Baknawar told, and that suspect has to be proved now is a criminal or not a criminal, then you can take even the pathological characteristics also and you can work on it, right? So this is what it is all about. So when you say computer forensics and when you say first forensics, they are first crime data. Link those crime data with normal data. Link those crime data with the abnormal data where there are deceased characteristics. Make a model, connect it with the machine, and try to find solutions. It becomes a very interesting prodigy. In India itself, we are having a lot of laboratories today, private laboratories. Like one of them is Sherlock Institute of Forensic Sciences in Delhi, and there is one legal company, a private one in Bangalore, which is called as Clue for Evidence, right? Because I have worked with them, I know it. I'm just showing you certain paths, because the workshop means I need to show paths to people where you can go, where you can work, and how you can diversify, right? And diversification is very, very important. Then you get a lot of opportunities. Otherwise it will be just fingerprinting, face recognition, and retinal recognition. Why not veterinary? And if you bring veterinary, for what? So if animal bites are there, or if animals have been killed, and if animal bites are there, what are those claws which were there, so that doctors can give better treatments to those human beings who have got animal bites, apart from the anti-rabies vaccine, because sometimes sutures will come, sometimes abscess will come. How to solve it so that gangrene will not come, etc., etc. Right. So with this, I end my talk. If at all you have any questions, you can put it to me now. Right.
Good morning,
Now it
sir.
will be Akshay Jaivital who will be giving talk on differential privacy. Yes, please.
Good morning, sir.
Yeah.
Sir, first of all, I would like to congratulate you. It was a nice discussion on this topic. It was very new to me. I have never heard about all these things. Secondly, I would like to know, is there any certifications on these cyber forensics?
Yeah, certification courses, if you want to do, you can contact Sherlock Institute of Forensic Sciences, Delhi, Dr. Ranjit Singh, right? And
Okay.
they have collaborative laboratories in Gurgaon, in Noida, and there are some fees also. Some small fees is there, but it is worth paying it and joining there, because top people from all over the world and from all over India are coming there, right? When I was
Okay.
taking this subject, cyber forensics in forensic medicine and toxicology, I was sponsored by my university to go there. So I thank my university, Manipal Academy of Higher Education. Because of them only I could go there. And when I went there, I should not tell it from my ego perspective. I was appreciated because I gave certain ideas. I won a prize there for that photograph analysis, what I showed yesterday.
Yes,
And
sir.
then we had a lot of discussions with all the top people from forensic science labs from North India and also from South India. And there were talks from abroad. There was a guy from the FBI, Federal Bureau of Investigations. I forgot his name, right? I think it was Guy Ritchie. So they had given talks in such a way that it was looking more academic in nature. We never thought that we are dealing with any crimes physically, right? There were some accident cases which were shown in Gurgaon, like a car accident happens, and then they had to prove that the driver who had driven is the person who drew the car. They could not do that because the surveillance camera was not very clear. So actually, it can be either a normal accident, or it could have been driver wanted to commit suicide, or driver had certain problems with the owner of that particular car. So there were three solutions given, but they could not prove any one of them because the surveillance camera on that particular on that particular flyover in Gurgaon was not having a very clear surveillance camera. So a lot of good examples. So you can contact Sherlock Institute of Forensic Sciences,
Sure,
right?
sir. Sure. Sure. Thank you, sir. Thanks a lot.
Yeah,
Good morning, sir.
yeah,
Deepak from Bangalore.
yeah,
Sir, you said recognizing the to identify the person, we are using a face as a biometric. Okay.
yeah,
So because face is the one biometric, if I use that one, that requires a user cooperation, something like that.
yeah,
So why can't we use something like a gate as a biometric for that? That is my first question. And the second
yeah,
question is whether you have any public available data sets for these things, sir, because you said these are the private data sets what you are using, and
yeah.
this cannot be shared. You said so. Any public
No,
available data
this can.
sets?
Mm. Continue.
Yeah, that's about that. Those two things, sir.
Yeah,
One is uh,
the first question what you asked,
uh,
basically we need permission. But see, when there is a legal case, if there is a suspect, so
hmm,
suspect, the word suspect will be given to a person only after evidences. So once there are evidences, that suspect can be brought to the police station, basically, or whichever place where he needs to be questioned, right? Even in the airports, right? If there is suspicion, if they find certain noise in the metal detectors, even I was checked many times, 2 or 3 times when I went abroad, a small noise in America, so they said we need to privately check you, so you need to cooperate. So once there is a suspect, basically what do you mean by suspicion? That there is a proof. So when there is a proof, so they show it, they will tell, see, there is a beep sound coming, or see, these are the evidences, we have seen your face like this, so we need to now have a recognition done. So when there is a suspect, recognition is going to be done, whatever the answer may be. Now the continuation of your question, we can use gates. Gates also are you, I think gates means you're talking about foot movements, right?
yeah, yeah, yeah. That's what, sir.
Foot movements,
Body
right?
movements or foot
Yeah,
movements. Yeah,
body movements, yes.
foot
Now
movements. Yeah.
remember, body movements, when you take, basically there are two types of body movements. One is upper body, that is above your waist, and there is the body parts which are below your waist,
Yeah,
basically.
that's what.
So whether the surveillance camera is able to capture both, right? Because
Mm-hmm.
lot of clues can be got by the way you move your body. Are you sweating abnormally, or are you making certain dance movements? Like I've seen this in one train. I remember when I was going from Bombay to Calcutta. I remember I was going by the Bombay Express train, and we were sitting in one berth in a three-tier coach. This was around 14 years back. And there was a girl sitting near the window, and I was a third person. There was a person sitting between the girl and me, male. And then immediately in Gondia, a place called Gondia, some 4 or 5 people boarded the train and they sat in our coupe, the six berths.
Okay.
And one person, a very fat person, slowly started whistling, right?
Mm-hmm.
And I didn't know what was happening because I was sitting not near the window, and this guy was sitting almost in the corner of the berth, basically. At that time, that girl was sitting in front of me in the front berth, basically. Then the girl asked me, "Can you come and sit near this window? I will sit on the other side." I agreed. Then what happened was this person slowly started pushing the other person. Then I came to know there is something wrong, right? There is some eye teasing going on, and these are the places where a lot of eye teasing went on in those days, specifically in Chhattisgarh and Maharashtra, because I am born and brought up in Raipur, right? Raipur and Bhilai, so I know. But now the things have changed. Then after this man, he went on doing it, and other two people also, they were making some bad, obsessive remarks, basically. But we were there, and then the girl was telling, I did not like. Yes, they were targeting that particular person, and perhaps, if at all we were not there, and if at all only one or two people, something else would have happened. It could have led to an abuse, but that's a different case altogether. Now, coming back to your question, gates. Now, what are movements here? This fat person basically made certain movements. He made whistling sounds. And those
Okay.
whistling sounds were very abnormal. We can make out. So if at all in the court of law that there is a legal provision to catch the person immediately, he will be immediately made as a suspect because the way he was whistling, right? There are ways even when you whistle. Sometimes your friend asks you, please whistle. That whistle will not be abnormal. It was abnormal. Then the body movements. He was moving abnormally. He was pushing his shoulder on the other person. And the other person was falling on somebody else. And then that person was falling on me. I was falling on somebody else. So these are all the body movements. But my body movement was very normal because I was falling because somebody else fell on me. And my face became a little bit abnormal because I didn't like it. So easily a person can say that I was not responsible for doing that, somebody else. So yes, upper parts of the body is responsible. But if the surveillance camera is not able to capture the upper parts of body, only the lower parts of body are getting captured. Say like your surveillance camera in the railway bogies are put down, they are not put up basically. Till date, we don't have surveillance cameras even in LHB coaches, but slowly now in Tejas Express and Train 18, which is called Vande Bharat Express, now surveillance cameras are being put on the top. But those surveillance cameras also can capture very clearly the upper parts of bodies. So the answer to your first question is yes, gates can be considered, but if all the gates are required of the human body, it will fail. So if there is a suspect, better go for the best biometric what we have. In anyways, we cannot solve all the cases successfully in the court of law because the court of law says either this person is a criminal or not a criminal. So from the court of law, from legal perspective, the case is solved, but whether the criminal is really criminal or not a criminal, that is the human perspective. So there are two perspectives of looking at your first question, human perspective and the legal perspective. So from the legal perspective, which data will be the best to be produced in the court? So I feel I'm right in saying faces will be the best one.
Okay.
Now your second question, what is second question?
Second question, sir, any publicly available data set? Because you said you have some private data set you've taken,
Yeah,
you have some.
publicly available data set, if you want to use, basically you have to take a ethical clearance. Even Sherlock Institute, Forensic Science Labs. I remember I went to the fingerprint labs in 2006 with Dr. Suresh Kumar in National Crime Record Bureau. I had to take permission from IIT when I went there, and then I had to give all my digital data, and then they had a health checkup of mine, so many things. So without that, you cannot get any of these crucial data. So let me be very clear.
Okay.
Neither I am going to share some of these data, but if internet data are there, I can share it. I'm not selfish on that, but I
Okay.
need to be ethical because many of these data are all crime data, basically, not only murders or abusers, but because when we say murders or abusers, people become very curious, and
Mhm.
curious minds can create more murders, right? Either emotional or physical. So the answer to your
Okay.
second question, am I right in saying the saying for the first question? Did you get my point? What I'm saying?
Yes, sir, yes, I got it, sir.
So
Sure, sir.
there is something called court of law and the human
Mhm.
perspective. From the
Okay.
human perspective, you will know कि इसी ने किया है, इसी ने
Mhm.
किया है. But the
Mhm.
court says no. The court acquits that particular person. So from the
Okay.
legal perspective, it is correct. From the human perspective, we know that no, he has done it. If you see the
Mhm.
Rajiv Gandhi assassination case, even still it is going on. Nalini, who was there, she says that I doubt that Dhanu was having the bomb. And she says that I did not know that Dhanu was having the bomb. Then they found one camera which fell down and they took the photographs of it. And if you see Simi Garewal's serial there, and there are so many other conspiracy theories behind if you ask them physically, but finally at the end of the day you know that she was a lady who was wearing the flowers behind, that lady Thanu, a pass out from Madras, one top university, and yes, she was what is that, brainwashed, and she blew the bomb basically. But if you ask Nalini, she says that I did not know she was having the bomb, and perhaps the evening before they were there in the same house, and a lady was called from Delhi, right? Another lady who was involved in this particular assassination. So there came the suspicion from where this lady came from Delhi and who supplied that lady for this assassination. I stop there. I don't talk more about politics. All right. All
Okay,
right.
sir.
Anything else?
Thank you, sir.
Yeah. Anything else? And mind you, all the examples what we have given, they're academic in nature. So let us not bring any other, because this topic is such, we need to discuss certain examples. They are all academic in nature, all right? We are not here to make any kind of comments by which it becomes a negative propaganda. So it's all academic, right? Anything else?
Any
Yeah.
more questions? Okay. If no questions, so your session was very informative. You made it interesting with your relevant case studies. So we look forward for your session tomorrow.
Yeah. Thank you. Thank you.
Hello,
Yeah.
sir. Hello.
Now I would
Hello.
like to invite Mr. Akshay MJ. Excuse me? Okay. Now I would like to invite Mr. Akshay MJ, Assistant Professor, Department of Information and Communication Technology. Mr. Akshay has done his BE and MTech from MIT Manipal and he is currently pursuing his PhD. I request Mr. MJ to take over the session.
Thank you so much, ma'am. Uh, Shrikant,
Akshay, can you please unmute yourself?
okay, I'm sorry. I had not unmuted, sorry. Uh, Good morning to everyone present here. And I think we have a bit of less time, so I will quickly get to the presentation of mine. And I hope it is visible now. Is it visible, ma'am?
Yeah, yeah.
Yeah. Okay. So many thanks to the organizers for having me, giving me this opportunity, and mainly my HOD, Dr. Balchandra sir, and all the organizers who are part of this program, and especially all the attendees who have been keenly listening to the address from Dr. Shrikant Prabhu sir, who's my PhD guide as well. So I'm going to talk about the area differential privacy and touch upon the information abuse. So we know that we can. I just want to hit on the background a little bit, where we have multiple users consuming data, generating data, and all this data is somewhere being stored. Maybe right now what we're recording or what we're using right now is also being recorded, and it's also being stored somewhere. So that is the original data set, and a lot of personal information has been also collected. You sometimes when you go shopping or many places, maybe hospitals, banks, online social networks, we have multiple apps these days. So it becomes important as to we just care about what happens with our data. So we're just using our apps and we are just happy with our usage. But what happens behind, and how is it being handled, and how is the anonymization taken care? That's where the uh, privacy preserving techniques needs to be applied. And on this original data set, we need to apply privacy preserving methods and ensure that the customer services finding in interdependencies, obtaining the official statistics, and mainly the main thing that we're going to be doing is mining for knowledge. So that is the end result, right? So what we talk about data mining. So I would like to hit upon a bit of data mining as well. I'll be moving through quickly on that. So we have several steps in data mining. So mainly initially we have the data, and then we select what we want, and then we do the processing, and then we have to transform it to the form that we want to, uh, and then you apply your data mining techniques, your clustering, classification, many methods that we have heard about, or we have learnt about. And finally the end user, or the even the person who's coding, would want to evaluate or interpret the knowledge that has been done, and you want to obtain patterns. So when I talk about patterns, so we generally typical example would be the market basket analysis, where you go to a store, you pick up some items, and the store owner will know what are the items that are generally picked up, so he can place his items accordingly, so that the users, even he is profitable and also the users are benefited. If an item is kept somewhere very remotely inside the shop, and if that's something that you want, so it's not easily accessible to you, although it's a necessity. So that's where the market basket analysis comes into picture. The there we have something called as association rule mining algorithms, and these are designed to find relevant relationships between the variables of a data set. And these associations are expressed generally by rules in terms of if I keep it here, what happens then? So if and then, so the condition and what is the result. So this is how the association ruling mining works. And people may buy from a local market every day, and this what we do is we are accumulating a lot of data, we are accumulating a lot of transactional data. Go to a shopping mall or maybe your online purchases, you are actually doing a lot of transactions and you're having a lot of transactional data being generated there. And after a few months of years, the data will be huge, the amount of data that is generated. And if actually it's so huge and you wouldn't know what to do with that data, so unless you do an analysis with it or do a mining and get some patterns and make something meaningful out of it, that's when you call it as knowledge. And the market basket analysis can be done to know what is customers patterns of preference of buying. So this is the main reason why this is done. And quickly moving on to the steps such as classification, where the word classification itself suggests you that you want to put something somewhere, you want to classify somebody, you want to classify an item, you want to. So for that to happen, even for us, for if I want to classify my relatives and my colleagues, so unless I know who are those people, so that's not possible, right? So that is the training phase or the learning step. The similarly it works for the computer science domain as well. So we have to train our model and then do the classification, and then you will see that how much of classification is rightly done, and that's where you calculate your error and you have your error forecasting measures for that. So a typical example where you can see here the training data, and you apply some classification algorithms, you have ID3 etc., different algorithms that are present, and then you once you train your model and you have a classifier ready, and then you any unknown data that comes into picture, you can, based on the training that has been done, you can classify them. Similarly, another unsupervised technique, this is a supervised technique where you are actually training it and then doing it. But what happens if you don't know? So if you want the system to learn by itself, so you have clustering techniques. So you have clustering or cluster analysis. It's a process of grouping of objects or observations into groups such that the object in one cluster does not have much of similarities with the object in the another cluster. So, for example, you have multiple branches in an engineering, or maybe you want to talk about different institutions. So you want to cluster them into different people, right? So as a university, we are one big picture, but you want to cluster them into different institutions. So based on similarity, in case of institution, the similarity would be the subjects that have been taken by the students over here. And so here what happens is the system learns from observations, and then the automatic classification is done. So while this is happening, we need certain criteria as to why how we doing this. So the factors affecting this clustering are mainly the partitioning criteria, and based on what are you trying to do your partition, and separation. So what is your separation measure? And in terms of similarity measure, when you have data points, so you would want to the similarity measure would be based on the Euclidean distance or Manhattan distance, etc. So and then the overall clustering space. So I'm just giving you a typical example of an institution, and wanted to briefly discuss on the. Now coming about talking about what is information abuse, right? So the information abuse is nothing but you compromise of information for which the data shareholders, which can be us or anybody else, are not ready to disclose. So I don't want my personal data to be given out, or what I use in my phone, I don't want it to be given out, but somehow it is being leaked. So it depends on the kind of information, the users involved here, and the access provided by your organization to the sensitive data. So now, and I spoke about privacy here, right? It somehow relates to something called as privacy. So privacy and data mining, they go hand in hand. and the data collection and data mining are applied in various domains. And the only problem is, what if the data is not correctly handled? So everyone, we all have a concerns of disclosure of private information. We all use social networking apps like Facebook, Instagram, or many other sites, and we will all be we will be thrilled, or sometimes we wonder how they are actually able to suggest the exact things that you want to look for. For example, one day I was having a conversation with one of my peers, and talking about somebody, and I was saying that person is not so good, and I just immediately got an article about that person, that he's a good man. So that's how much they're listening to us, and that's how much the data is being shared and mined upon. And so when it comes to privacy preserving, what are the different privacy preserving techniques? I will hit upon those and give you a comparison of different strategies. And so what happens when your privacy is not maintained? So the first and foremost thing is that you end up leaking individual records, and at the same time, you should make sure that you cannot be linked to any public database or re-identify individuals. A typical example, because we all are part of a university, we have students' academic data, and we have their academic status. And generally, when you would have noticed, even in your examinations, we generally don't get to know their registration number or name, because this should be an unbiased evaluation. And but that is that enough by just not giving the registration number and name? By actually we can find the patterns how they've done before, and maybe you can actually find out who they are. So it becomes important as to what privacy preserving techniques that we imply, and uh, uh, get the best out of it. So here we have two conflicting goals. So I'm talking about preserving privacy. At the same time, if I apply too much of noise to my data and do an analysis on that, probably it's not of much use to me. If I want to do some analysis about the patterns of people purchasing something, and at the same time I want to take care of their privacy, so there's two different there are two conflicting goals. So that's utility and privacy. So there should be a trade-off between these two terms. So the utility should be maximum. At the same time, privacy also should be maximum. So if both cannot be maximum at the same time, so ideal situation is that when both are max, but we have to find a trade-off in between these two, so that the utility is also at the maximum level. At the same time, privacy is not given off completely. So utility means you modify or even removes some of the original data in order to preserve privacy. So this quality degradation is known as the natural trade-off between the privacy level and the data quality, which is known as the utility. We need maximum utility to conduct effective data mining. If we don't have maximum utility, then it becomes that whatever analysis you're doing is not necessarily giving you what you want, or what exactly you're looking for. Maybe the predictions that you do or the mining that you're doing is not really giving out the exact information that you want to infer from that study. So I will just also now talk about different attacks that have been done on privacy, some major examples. So the AOL data release attack, where the AOL it's a search engine which had released search keywords of 650,000 users over a 3-month period. User IDs are replaced by random numbers, but 3 days later, people could identify, even though the user IDs were replaced, but it was not hard for re-identifying the people, and that's how the privacy attack was done over there. And in the next attack, which is the group insurance commissions in Massachusetts, and so they collected patient data for more than 135,000 state employees, and they gave to research and sold to the industry. And the medical record of even the governor was identified, even though they have changed everything, or some of the fields or the attributes, but it is not enough. So we need to have more privacy preserving strategies. We need to have a certain amount of noise being added. So, and the next example is the Netflix movie rating data. Most of us are using these apps these days. So Netflix released an anonymized movie rating data for its Netflix challenge with date and value of movie ratings. And knowing about 6 to 8 approximate movie ratings and dates they were able to uniquely identify record with over 90% probability. So again, so here also there's a privacy loss, and the whole point of releasing the data to do an analysis was lost. So, and the utility was probably maximum, but at the same time privacy was lost here. So, and the other famous study is the genome-wide association study. The study examined thousands of SNPs, which is the single single nucleotide polymorphism locations in a given population of patients for statistical links to a disease. From aggregated statistics, one individual's genome and knowledge of SNP frequency in background population, one could infer the participation in the study. So again, the membership disclosure happened here and the privacy was lost. So these are some of the just attacks I wanted to talk about privacy. And now coming to the topic, which is the differential privacy. So what is differential privacy and why does it matter? So in recent years, there's been an explosion in the amount of personal data being collected, and data now flows from every business transaction and from our mobile and social media activity, and increasingly it flows from the sensors embedded into our daily lives too. So collecting and managing these data also creates significant privacy risks. So fortunately, in a world that we're living in, where the risks and the costs associated with the privacy are on the rise, so the differential privacy offers a better solution. We are a threat. We are the amount of data that we are generating, amount of data we are giving out is actually not good. And at the same time, if we, that's the reason you might have recently known that there's so many the MNCs, big conglomerates such as Google, Facebook are all going through legal procedures based on because of these data privacy issues. While that's the reason it opens a big door for the application of differential privacy, and it gives out a vast array of possibilities to develop applied AI solutions using differential privacy. So what is differential privacy? Again, this was just a brief understanding. Basically, it's more less lines of code and more of understanding of mathematics there. So it's a mathematical definition for the privacy laws that results to individuals when their private information is used to create AI solutions. So it measures how effective particular techniques are at protecting the privacy of individuals within a larger data set. After all, the more training data you have, the better models will perform. So similarly, I did speak about training and testing in the beginning. So even here, we need a lot of training data. Only then we'll be able to, come out with better models of for protecting the privacy using differential privacy techniques. A lot of big companies like Google, Uber, Ola, they're all using differential privacy techniques to ensure. Initially, you might have noticed when Ola or Uber, when we all signed up on it, and the drivers could easily access your details because they used to give out the numbers to them and find out where we are and to reach out to us. But we also saw that there were many issues that came up where many people were harassed, many people were threatened and everything. So they realized the need of differential privacy and why they need to actually protect the privacy of a customer or the consumer. And this is where the differential privacy came into more into picture, and it solves the differential privacy solves this by enabling insights for new customers using the data from the existing ones without even compromising the privacy. So even when a new user comes, it's easier for a company to get an insight on what they might like based on the training data that we have. That's why initially a lot of companies, when they start off, they give out a lot of offers because they want more people, because they want to have more training data. So once they have more training data, then after that they stop giving out these offers. Maybe your food applications like Swiggy or Zomato, initially when they started off, they just threw offers. They gave such a competitive price where people felt that they don't need to go to a restaurant to buy food and they can order it for a much lesser price. But it all comes at the cost. For the consumer, they were very happy. They got the discount. They got the best food. But at the same time, we don't know how much data they've collected from us, and they've also understood the patterns of our liking, and everything is so much behind it. Even like apps like music apps like Spotify, they they have such complex algorithms that is running behind. You might be just playing your search a song and just play it, but amount of analysis being done behind to understand what are your likings, what are the patterns, and even when any new person, newborn comes into a picture, so it becomes easy for them to give suggestions and throw insights. So how does this differential privacy work? So a differentially private AI solution may use techniques such as injecting noise into a dataset to protect the individual privacy. So the end result of a differentially private dataset or a model cannot be reverse engineered by an attacker. That is the main one of the main key things. You don't want an attacker to identify what is the original data there, and differential privacy then provides us a measure of how well that noise is helping to protect the privacy of the individuals in the data set. So, and while inserting these random noise or bits into the data, it doesn't completely prevent attempts to cross reference the data with other sources. So it does make it virtually impossible to identify specific individuals with full certainty. So I will now also start about how to get started with this. So we often nowadays we are quite used to filling out Google Forms or any other we nowadays collect a lot of data maybe from students or different maybe companies, etc. So you first need to identify what is that information that you wish to gather, and the second thing is that do you really need it, and main thing is that sometimes we might not necessarily need all the personal data, but we end up asking. I think it's quite common, and we just don't worry much before giving out our phone numbers when somebody asks in a shopping mall or anywhere else, because all that they want to is build up their database, and for us it doesn't make much of a difference at that point in time. But you might have over the period noticed the amount of the WhatsApps or the messages that you're receiving have significantly increased compared to last 10 years. The amount of ads that you're receiving, how are you receiving it? Because you have somewhere you have given out your data, your numbers, and they are somehow they're doing targeted marketing using those techniques. And you have some tools to achieve this goal about differential privacy. I am not going to show each and everything. I'm giving out the links here, so you have it's an open source link which is on GitHub. So you can the Uber tool, and also the Google tool, the Rapport tool, and the Immuta company tool. There are quite a few. I'm just naming the few which are quite famous and used very recently. And in differential privacy, what happens is that the attacker, they try to send queries and find out, right? That's what we're trying to say here, the privacy loss here. So the interactive database query is one of the ways where they're trying to find information. If you have an interactive database, they do a lot of query and they try to interfere in the existing transactions that are happening and pick some data. You might have also heard there's an attack which was done where people were stealing only like few paise from every account. So generally we don't notice that, or we don't actually care much about it, because if you lose some 10 paise from your account, we would probably not worry much or not even notice that. So people have done that, and they have access to some bank databases and snatched every bit of like small pieces from the account users, and eventually accumulated in crores. So this is certain an example why we need to have strong privacy preserving techniques as well as strong security in your data. So this is a classical research problem for the statistical databases, and it basically you have to prevent query inferences. Malicious users should not be able to submit multiple queries to infer private information about some person. So this study has been done from decades ago, and it continues to add more light into this. And we have several mechanisms. I'm just going to talk about some old mechanisms such as Laplace and exponential mechanism. So again, here they add a Laplace noise to the data and modify the data accordingly and ensure that the data is not exactly the same as it was originally. So this Laplace mechanism is suitable for numeric output. So for example, I've just quoted a simple example where we want to find out how many people in this room have a blue shirt, although we are sitting in remote locations. So how many of you are wearing blue shirts? So and exponential mechanism is suitable for non-numeric outputs, where what is the most common shirt color in this room? So in case if it is blue, then this is the difference between the numeric output and the non-numeric output. So the Laplace mechanism is that the query is sent by the user, and the private database, there the noise is added and the noisy answer is written back to the analyst. So that this is the Laplacian noise, and based on the sensitivity or the privacy budget that we actually set it, based on that the noisy answer is written back to the analyst, so that there's not much of damage to the original data. And at the same time, analyst also wants to have a data which is useful to him. So that is the key here, which is the epsilon where you see here, which is the privacy budget. So the epsilon controls the privacy guarantee level of mechanism. A smaller epsilon or the privacy budget represents a stronger privacy. So normally the value is less than 1. You can see the small graph that is there here. You see D is your original data set and D star is the modified data set. So see, you can see it's not the same, but there is a slight modification. At the same time here, if you make it too much of modification, then you will lose the utility of the data. So protecting the utility and the privacy, we apply the privacy budget accordingly based on your need, and apply the DP mechanisms using Laplace, exponential. There are so many like K anonymity, L diversity. We can talk about it and explore more about it. The greater the privacy protection, the less the accurate the results. So that's what happens. If you try to focus too much on privacy protection, the results that you want to give to the analyst will be less accurate. So this is called a plausible deniability. And now you have multiple algorithms you want to apply for a data set. So that's called composition theorem, where M1, M2 or many are the algorithm that access the private database D. And if each of these algorithms satisfy a privacy budget or a differential privacy, then running all these algorithms sequentially is nothing but a summation of your privacy budget. So this is the typical example. And now when we talk about all this, you come across a term sensitivity. We have that it's not the tooth sensitivity that we have, it's the sensitivity where we're talking about the global sensitivity, which considers the maximal difference between query results on neighboring datasets. You can see that the initial population on the first image, and then if you just remove one person, so that means you're just one less than the original dataset. So the sensitivity here is 1. So the sensitivity is nothing but measuring how sensitive the output of the query is to a person being removed from the database. For a simple sum, this is just always 1. But for the mean, when removing a person is going to change the result of the query roughly 1 divided by the size of the database. So you have the different ways of accessing the private data, mainly where the analyst tries to access some private database, there will be a privacy firewall. And when the analyst, they'll write a differential privacy program, and it is when the analyst is writing the program and sending it, it's very hard to verify whether the program satisfies the differential privacy or not. So the accuracy cannot really be guaranteed. So at the same time, the other way of doing this is that the queries are done on a live database, one at a time. So this is susceptible to side channel attacks, where a side channel attack simply means it's a security exploit that involves collecting information about what a computing device does when it is performing cryptographic operations, and using that information to reverse engineer the device's cryptography system. So here again the results are not very consistent. So the next solution that you can think of, you have a private database, you don't want to give out directly from that. So what you can do is you can create a synthetic version of the base tables. So it is not the original dataset. So again, you cannot do multiple joins on these because it's already a synthetic version of it. And the joins on these synthetic version or base tables might have high error when it comes to that. So here the analyst will not even reach to the private database before the privacy firewall itself you have given out. So they'll be doing their query and taking the results from the synthetic version of the database. So there are several design methods on how to do this. So the queries are generally sent by users, and the system should generate a DP algorithm for it. Either that's the best way, or the queries must be answered on the synopsis that is created, or the synthetic version, the synopsis that is generated on the views and not on the base tables that were originally created. So based on the workload, we can decide the size of the synopsis. So this is how a typical image would look like on how the after applying the different privacy techniques, and you can see the epsilon, which is the privacy budget set, and they have created the views or the views of the private database and taken a synopsis of it, and then the analyst only works on them. So this is how the typical querying the database works like, and what happens, or the what are the different privacy preserving strategies now, and we have to do a comparison on that. So I'm just going to show you some of the study that I've done, and put it in different uh, tables. So the different privacy names you would have heard of: encryption, anonymization, right? So encryption, you have public and assigned to transmit the data that are then used to decrypt and data at the receiving end. So we do have that. So, and advantage here is that the original data is not lost. You're just putting just a security key. For example, your own phone, you just have one passcode for it. So if somebody else knows that passcode, they can use your unlock your phone and use it. Similar to that. So it is just, I'm telling you a general picture, although the encryption itself is a much bigger topic to talk about. And the disadvantage is that it is actually computationally complex, it reduces the system speed, and it is not very suitable for public databases. So, and then when it comes to anonymization, so is it enough which we just remove your name and registration number of a student to make an analysis on that? Probably not. We can still probably identify the individuals without those fields as well. So the personal identifying information like name, date of birth, when you request the data from any government agencies, generally they remove all this. When you maybe in your what is publicly available for your maybe a census data or anything, they won't give out our name or date of birth, but then they give out the rest of the items, the attributes. Probably that anonymization technique is sufficient for a certain extent, but not. But you cannot really ensure all the time that the anonymization technique is really holds good. So it limits the disclosure risk, but it works well with very high dimensionality. When you have multiple attributes, it really helps. And the original data is definitely lost because you removed a certain number of attributes. The 100% privacy is not guaranteed in this case, and the chances of re-identifying exist large data. So the comparison of privacy techniques with the help of differential privacy, over here we have we spoke about the random noise being added to various mathematical algorithms using Laplace, Gaussian, etc. That I spoke about only Laplace and exponential. You have multiple other things that where the noise can be added. And the advantage is that the complexity is low with respect to this. Original data is not completely lost, and the privacy can be controlled according to your privacy budget that I spoke about, the epsilon. That is the value that you choose to decide on how much you want to give out. So disadvantage is that if the dimension is huge, it is not very conducive for using the differential privacy on that. There is a reduction in data utility because you are applying noise and modifying the data. At the same time, selecting desirable trade-off between privacy and accuracy is quite tough. So now I spoke about utility and privacy. So utility and privacy, if you have to do a comparison with respect to these three techniques, such as anonymization, encryption, and differential privacy. So what are those? So in case of anonymization, the constraint is that the limited privacy. Anonymization does not guarantee complete privacy, as it is claimed that anonymized data is either protected or either usable. So because the chances of re-identification always exists in anonymization. In terms of encryption, the third-party privacy, that it protects data from third-party intruders along with providing complete privacy. But the privacy is not protected from observing analysts. So when it comes to differential privacy, there is a trade-off between utility and privacy. It deals with both utility privacy trade-off that can be controlled by the data provider according to the privacy requirement. So I think if I'm running short of time, ma'am, maybe I will quickly wrap up in 2 minutes.
Yeah, sure, Akshay.
Okay, so do one thing. I wanted to talk more about the methods on privacy preserving techniques. So here we have two things where I'll just quickly brush upon. One is data sanitization, other one is anonymization. So when it comes to sanitization, you have two things where you either do input perturbation or do output perturbation. So input perturbation nothing means adding noise to the data and generalize the data. Output perturbation means you there in input perturbation you are modifying the original data. Here you are modifying the results, the sum or the count or the max mean variances that you are generating out of your data set. That is the one being modified here. So while adding noise itself, you have multiple ways of doing it. You have additive noise, you have multiplicative noise, and when it comes to anonymization techniques, I will just mention them now because we are running short of time. So you have K anonymity, L diversity, T closeness, personalized privacy, and other perturbation techniques are nothing but the downgrading the classifier effects so that data is sanitized, reduce the accuracy of the classifier itself. And other one is the relation rule hiding, which is the association rule hiding. And the other one more technique is the query monitoring and inference check. So I will definitely share these resources so that if anybody interested can go through more on this. And different privacy preserving models are there. Like I already mentioned a few. Mainly we are concentrating on differential privacy here, and the different privacy preserving approaches where we spoke about perturbation, anonymization, suppression, generalization, randomization, data swapping, etc. And the various attacks also we spoke about, and that is we spoke about some of the AOL, Netflix data attacks, and there are many linkage attacks, which is the record linkage, attribute linkage, table linkage, and probabilistic linkage, where record linkage you're trying to link between one letter to another based on certain similarities. And we have to ensure privacy in data publishing. And how do you ensure that? So you mainly do that by reducing the dimensionality of the data and apply noise on it using different sampling mechanisms, and then combine the attributes to form new attributes to reduce the dimensions. So it will be very problem specific. We cannot generalize on how exactly, we cannot use one algorithm and say this is the best algorithm that you can use for any data set. It's not possible. It will be very problem specific, all of them. And the different challenges and aims, if people would like to go on this. So mainly for any given data set, making it differentially private and secured will be the first task. And the second task would be extracting the features through various methods while ensuring DP, which is differential privacy. And then the task 3 would be finding the utility and accuracy. These are the main 3 things. Mainly, you have a data set, you want to make it differentially private and secured, then you extract the features using different methods that we have in differential privacy, and then finding the utility and accuracy. So I wanted to show also a bit on the academic data that we have, how when someone queries this database, if I remove somebody from the database, would the output of the query be any different? So in order to do that, I have to create parallel databases, and how it can be done can be further explored on this. And to summarize or conclude, the business organization constantly collect data, and because they want to improve customer services and also improvise on the benefit for their own companies. So privacy preserving methods help in extraction of this knowledge without harming the privacy of individuals. So extension of these techniques to our planned datasets will reveal interesting results and have an impact on the society. So the information abuse research will contribute towards newer problems to be worried in the data generation era. So this is where I would like to conclude now, and thank you for this opportunity and for a patient hearing. My references for this, and any questions I will be happy to quickly take it, because I know you have another session coming in 15 minutes, less than 10 minutes probably.
Yes, any questions from participants?
I'm sorry
Okay.
that we had to
Yeah.
rush through the presentation, but I hope, yeah.
Yeah, I think there is one question.
Yeah.
Sir, I have one question, that what shall be the impact of GDPR with respect to Indian data privacy?
Yeah, I mean, GDPR is something that we all look up to, because based on their standards only, we all have to nowadays work on it, right? So,
Yes, sir.
based on the standards set by the GDPR itself, nowadays every company, when they're starting off, they need to ensure that maximum care is taken care, they comply with all the GDPR regulations and everything. So, that's like the Bible or the Bhagavad Gita or the Quran for data privacy.
Okay. Thank you.
Yeah, thank you.
Okay. So, Akshay, in a very short time, you made sure that you cleared all the points. It was very informative, and I'm sure our participants are benefited. Thank you for your session.
Yeah, thank you so much, ma'am. Yeah. Thank you for the
Yep.
opportunity, sir.
Yeah. So participants, new link will be shared with you. So at 11:15, you need to join with the new link which is shared. Okay, you can leave this meeting and join the new meeting with the link shared with you. It will be shared via email as well as through our WhatsApp group. Thank you.